think we haven't talked about it yet. Is at least one stuff. So let's do some. Here I'll show you how to think about these. So I didn't fill out the N yet. So we're gonna say like in this first one, taking a multiple choice test, A, B, C, D are your 4 options. Let's say there's 5 questions. So that's your N. 5 questions on the test. And this is what I really want to know. At the end of the day, I want to know the probability that I get at least one question correct. This is just kind of like me guiding you through the thought process. So if it's a multiple choice test, you've never seen the material before, you're randomly guessing it's A, B, C, D, what's your probability of succeeding? 1 out of 4, right? So we can put 1/4 and we can put 0.25, whichever. And then your probability of failure, the probability of going wrong, would be 3/4, right? 0.75 if you want to say it that way. So before I do that, I'm just gonna like down here sketch. I could get 0 questions correct. I could get 1 question correct. I could get 2. I could get 3. I could get 4. I could get 5. Those are the only possibilities, right? This is how many questions I can get correct. Well, I'm asking for at least 1. So what I really want is like those all totaled together. The probability I'll get 1 correct. But that's really hard to do because it could be the first question, the second question, the third question, the fourth question, the fifth question. Probably I get 2 correct. Well, now it's even harder. It could be the first and second, first and third, first and fourth, second and fifth, second and fourth. You know what I mean? Like there's all these different combinations. So, and third gets even tougher. So I'm not going to find, this is what I want, but I'm going to find that without ever finding it. Because what do all of those things have to add up to? They have to add up to 1. Because don't I 100% of the time have to get either 0, 1, 2, 3, 4, or 5 correct? So this is all the possibilities. So all of these things have to add up to 100%. Again, I'm looking for this, but what I'm going to do to find it is find this. And let's say this was 0.2. Then what would be the probability of at least 1? It would be 0.8. So we're going to find the probability of failing every single time. Because the opposite of failing every single time is succeeding at least once. Right, so the probability of no successes is I want to fail 5 times. What's the probability of failure? 3/4 or 0.75. So I'm going to do that to the 5th power. Figure out what that is. Syntax error. Cool. 0.237. So that's the probability that I get no successes. But I actually want the literal opposite of that. I want at least 1 success, right? So what am I going to do with that number? Subtract it from 1. So 1 minus 0.237. So 0.763. So this, in this example, was 0.237. This is really what I'm interested in, but I managed to find it without finding it. So this comes out to 0.73. It's 0.763 because these two have to add up to 1. If you went through and individually found all those, it's a giant pain. We haven't even talked about how to do it yet. We don't have to. I can just do it this like backwards. Question on that first one? Does that make any sense? Okay. Alright, true false test. What's the probability of success? 1.5. What's the probability of failure? 0.5. Let's say that there is a 7 question true false test. So try to find those next 2. The probability I get no success, and then the probability I get at least 1 success. Mamma Mia starts like 2 weeks. Are there 3? 2? Yeah, I was thinking it'd be like second semester. There was 2. Oh, so yeah, it takes like that long. I get you. So the play will be in March. I start like getting ready. Okay. When's like casting? So that's a ways still. Are auditions and casting like the same time? Okay. Gotcha. Okay. You're what? Gotcha. We haven't like heard it. Okay. So 7 questions. I want to get at least 1 right. So this is what I want. That's the information I'm looking for. That is way too hard to find, and it's beyond what we've ever done. So I'm not going to do it that way. So I'm going to find the probability of 0 successes, which would be 0.5 to the 7th. I failed every single time. And just to make sure we're on the same page here, that's this 0.5. Because I got the same number, right? I'm doing the failure 0.5 to the 7th. So that's 0.0078. So this is 0.0078. But what does all of that have to add up to is 1. So if I do 1 minus 0.0078. 0.9922. There's a chance that if I take a 7-question true false question, that's at least 1. How many had that? Questions on what I'm doing? Let's see what we got. Alright, let's say we make 70% of our free throws. So this probability of success is 0.7. Probability of failure is 0.3. Let's say we shoot 4 of them. Go ahead and try that one. So, probability of failure is 0.3. I want to fail 4 times. I want to know the probability of fail 4 times so I can subtract it out. That's 0.3 to the 4th, which is 0.0081. That's 0.9919. Those two okay? Or is that okay? Alright, let's say, so this 30% chance Ben comes to class on time. 70%, is that about right? 70% chance he doesn't come to class on time. Let's say in a week. So 5 days a week. What's the probability that he gets here on time at least once? So, wait, no, this is wrong. So we take the probability of failure and raise it to the 5th power to that realize like on your test or in con, like that part won't be there, right? It's like me trying to guide you through it. Maybe on your next one try. So I'm just gonna say try that. Try to like think about it as though that's not there. And just do it like. I mean, you might still do those steps, but you know, on the test it's not gonna guide you through it. So try to not be guided through it. Yeah. Rolling a 2 or lower on like a regular die. So how many? You know, there's 6 numbers. Oh, that's yeah. Okay, yeah. My bad. Let's say 6. Be careful on this if you're using decimals. Like the probability of roll a 2 or lower is 1/3, right? But if you type in like 0.33, by the time you do it to a bunch of powers, it's off. So if you're gonna use decimals, do like 0.3333333333, or do like 1/3 in parentheses. Because it does kind of matter when you start raising it to a power. So here's what I'm talking about, just to show you like how far off it is. Because you're doing 2/3 to the 6th power, right? Then you do like 1 minus that. 2/3 to the 6th power is actually 0.087779. If you round it like 0.67 to the 6th, that's not way off, but it's off enough that you might get it wrong. And even if you did like 0.67 to the 6th, you know, that's not the same as that 0.0877. But if you do 0.66666666 and you just do a bunch of times, that'll get you there, or do the fraction. Otherwise, you're going to be off by a little bit. So probability of no success is 2/3 to the 6th, which is that 0.08. Let's say 0.0878. This will be 0.9122. Question out? Alright, now let's say your chance of winning the lottery, let's say you're going to play 10 times. Your chance of winning is 0.00001. What's the probability you win at least once? Bless you. That's 4 zeros. So you might get this 4.9. This is what I told you. 4.99 e negative 5. I might get that. Remember what that means? You didn't get that? Or did you just get like the regular decimal?
Yeah, 0.999900004. Unless I put it in wrong.
So I think you're just wearing different steps. So the probability of success is the 4 zeros and then 1. And the probability of failure is like 5 nines. Right? So if I do this to the 10th power, I got 0.99995. You with me there? You didn't get that?
It was like 0.9999 and then like 4 zeros.
Oh, I did it to the 5th power. Okay, so 0.99, just 4 nines. Yeah, and then 1 minus that. Oh, so mine still gives me the. Okay, this is the point I was trying to make. It's still. Yeah, so did you get this? When you do 1 minus? 1 minus. You get that.
Yeah, I got
yours says,
Mine says 5E -5. So basically what yours is, but mine says 5 instead of 4.99.
do other people have this?
Yeah, I also have that.
So that's just like rounding. You put a 5. I think you put a 5. Yeah, that's my bad. But anyway, I wanted to just like remind you what the E was. So the E means you're going to take that decimal and go 5 places to the left because it's negative. So you go 1, 2, 3, 4, 5, and then in those missing spots you put zeros. So it's like 0.0000999. If you got the 1 thing, that's the same thing. What's up? What did you get? That's for this one though, right?
Then when you do 1.
And then you got to do 1 minus that still. But I don't know if they all show E's or some just get decimals. Yeah. Yeah, so if you take 0.0000099 and round it, it's 0.0001. Like that 09 will go up to a 10. That's fine. If you want to use a calculator, like a second grader would use, that's cool. No, it's fine. That's not a wrong answer at all. I don't like how that ended because let me make one more. So multiple choice test A, B, C, D, E. 6 questions. Find the probability of at least 1 correct. And this is good too because it's not like me guiding you through it. It's just like that's how the question would look like on your test or the AP test. So you've never seen this material before. You're in like Calc 12 and they give you a multiple choice test. First of all, just kind of think through, like, am I probably going to get at least 1 right? There's 6 questions, I'm guessing I'm probably going to get at least 1. Let's say pretty likely. So my point is, if you get like 0.001, or something tiny, that should kind of throw you, like, make you reconsider. There's 6 questions. If I get to guess 6 times, I feel like usually I would get 1. So the probability of success, I don't know if you wrote this out every time or not, but I'm just going to. Probability of success would be 1/5. Probability of failure would be 4/5. So the probability of all fails equals 4/5 to the 6th power, which means the probability of at least 1 success is 1 right equals 1 minus 4/5 to the 6th power. I got 0.738. You guys agree? Question on it? Why do this? Where does this come from? Gucci. How come it's Gucci and not some other like fashion name? Are we fine? So you have the rest of the time today to work on an idea. I don't have anything planned for tomorrow except to give you time to work on cotton. Like I don't know, this years. So I'm not going to like teach you a lesson tomorrow. If you're done with cotton, bring other stuff to do.
Test is not 2.5.
So I found out why 2.5 is optional. Yeah, and part of it like isn't. So I looked at that part. And I'll make sure we get to the part that is. But so yeah, when you get back, we're done with like the. That's actually a great idea. So Monday we're gonna do probability trees a little bit more. And then Tuesday will be review. The con is due. And Wednesday will be your test. Avery, you look